So you may have noticed I skipped example 3.4. I'm going to reserve examples like that, the matching games and true or false questions, for something we do during workshop. So let's skip to example 3.5, which actually is going to be really nice to notice the similarities between these two examples. So the last example that we did together was to find this tilted circle. Now let's put some context on that problem and maybe see where this tilted circle is coming from. So my question is to find a vector function that represents the curve of intersection between the cylinder x squared plus y squared equals 1 and the plane y plus z equals 2. So far we've taken vector equations and tried to graph them. Now we're taking a graph and trying to come up with a vector equation. And so what kinds of things can I use here? So it has been really useful in the last couple of examples to know the parameterization of a circle, right? Everything so far, and it's actually, it's certainly not true for every example. We'll look at some during workshop where I don't have circles, but circles are fun to work with, and we know how to parameterize them. So I maybe am going to use the fact that this lives on a cylinder again. Right? We always have this property that x squared plus y squared equals 1. And so maybe I'll cheat just a little bit. Let's just say, what if cosine t was x and y was equal to sine t? What would that look like? Well, again, top down, this would be a circle, right? Certainly I would always be living on the cylinder. And I guess the question is now, how could I somehow get both of the information here, right? The height, but also the fact that this lives on a cylinder, right? So I want to know height in terms of t. Literally, I'm asking, what is z equal to, right? Well, z, by my equation, y plus 1 equals 2, z is certainly 2 minus y. And if I commit to a choice that y is equal to sine t, then I should have z equals 2 minus sine t. And so you can check on GeoGebra, you can actually graph this, or you can verify with the example that we just did that a parameterization of this intersection, if I commit to cosine t being x and sine t being y, then as long as z is 2 minus y, which is 2 minus sine t, I'll get my intersection. So test it. Go into GeoGebra or go into your favorite three-dimensional graphing utility and actually graph this curve to see that it is a tilted circle. It is literally the intersection of the cylinder that we're looking at and the plane.